little review of what y'all have to do for your pre-lab and what y'all are going to do in lab. And then I'll start working on some of the topics that y'all are going over in class. And so I made up a set of functions that's very similar to what y'all will be doing in your lab. Is it tomorrow? Do y'all have lab on Tuesdays? Yeah. And you have a pre-lab to do before you go to lab. And by the way, in Digital Logic 2, making sure you do the pre-lab is always very important. People who don't do the pre-lab don't finish the labs in general. I mean, the early ones are not as bad, but they get more to where the stuff you do outside ends up being really important. Okay, so we want to design a circuit that takes as input 4 variables, A, B, X, and Y. I think for y'all's it's I, J, something and something. It has output C and D. The variables A and B determine which of the following 3 functions should be implemented. And you're supposed to do all the same stuff that you would do at the lab. I just didn't copy all of that. So it's all the same stuff that the lab tells you to do. Basically to design the circuit, minimize it, and figure out what the chips are going to be. So the first thing you need to do is to decide how you are going to determine the functions. And so you have these 2 variables, A and B, that are supposed to determine the function. And A and B could be 0, 0, 0, 1, 1, 0, or 1, 1. And assign each one of those to one of the functions. And there's no rule as to how to do it. It may end up that doing it one way gives you a simpler function than doing it another way. I'm going to do it like this, F, G, and H, and then 1, 0 is not defined, and so that's going to end up being don't cares. So if A and B are 1, 0, then we'll have don't cares. So that's the first thing that you need to do, and it's up to you how you decide to do it. I mean, it's just however you want to apply it. So then you have your 2 outputs, C and D. And this is what a Karnaugh map does, is you figure out what is the circuit the function that makes that output. So I'll start by looking at C. So I want to figure out what combination of variables makes C whatever output it's going to be. So I have my 4 variables. I have A, B, and then I have X and Y. And A, B can be 0, 0, 0, 1, 1, 1, or 1, 0. And X and Y can be the same, 0, 0, 0, 1, 1, 1, or 1, 0. And we decided that we were going to have 0, 0 be F, 0, 1 was G, and 1, 1 was H, and 1, 0 was don't care. So I'm going to go ahead and put in don't cares in the 1, 0 column. Now, if A and B are 0, 0, that means that we're in function F. So the way this is going to work is the TA is probably going to come to you and say, all right, I want you to select function G. And then you'd look and you'd say, okay, I did 0, 1 as G, so you'll set your switches 0, 1 for G. And then the TA will tell you, all right, now set X and Y to be whatever. And so you have to know how you set these up. So if I'm at function F, then when X, Y is 0, then C is 1. And if X, Y is 0, 1, then C is 0. And for 1, 0 and 1, 1, C is 1 for both of those. Now, if instead I'm supposed to be doing function G, then I would set the switches that are for I and J or A and B, I would set them to 0, 1. And so that means I'm implementing function G. And if I do that, this middle one gives me the values for function G. And so if x, y is 0, 0, C is 0. If x, y is 0, 1, C is 0. If x, y is 1, 0, C is 1. And if x, y is 1, 1, C is 0. So right now I'm just determining the output for C. So I'll come back and do D after we finish this. Yes?
I'm sorry, just to double check I'm understanding this. So
yes.
Basically, AB allows us, is a switch telling us which logic to use. So it's like a switch telling us
two switches.
Yeah, two switches saying which of the four chips we use, with the fourth one being a don't care.
It's not chips. It's which of the four functions are you implementing. So think of it this way. Pretend it's not these functions. Pretend it's add, subtract, multiply, divide. And so you are given two numbers that tell you whether you're going to add, subtract, multiply, divide, and two other numbers that you have to do that to. So I say, all right, so you would say, all right, so you would come up with whatever scheme you wanted. And I would say, okay, I want you to divide. Okay, so then you would set those switches to 1, 1. And then I'd say, okay, the two numbers I want you to divide are, well, pretend that we're not in binary, but, I'd give you two numbers, 10 and 5. And then you would set those switches to be, the binary numbers 10 and 5. And then it would do that. And so that's what those are doing. So those two switches are just telling you which of F, G, and H you're going to apply. And those are functions just like add, subtract, multiply, and divide are functions. They take two inputs and give you one or two outputs.
All right. Yeah, that clarifies things. Thank you.
Okay, you're sure it makes sense?
Yeah.
Okay.
We're telling us, like you said, which function do we use, and then we have separate inputs for those functions.
Right. And so, like in this instance, if x and y are 0, 0, so that's x, that's y, and a and b are 0, 1, that tells you I'm using function g, because that's how we defined it. And then function g, that's given to you, or is given to you in your lab handout. Function g, if x, y is 0, 0, c is 0, and d is 0. You get two outputs. Okay? All right. Now for C, you'll notice H doesn't have a C output. H doesn't care what C is. And not caring is a don't care.
And this information with 0, 0 being F and 0, 1 being G, like that would be given?
No, you get to decide that on your own, on your lab. I mean, it could be given, but just in your particular lab, the instructions say, come up with this on your own.
Okay, so it doesn't really matter which one?
No, you just have to know what it is in order to make yours give the right answer. There's not a right way to do it, but you have to you have to do it right for yours.
Okay.
Yeah. Okay, so here this. Did I fill this in right? This simplified nicer when I did this morning. I must have assigned these functions differently. Okay, so this bottom row.
Is G 0010?
G is, no, that would, so you got to be careful because the truth table is in the order 00, 01, 10, 11. But the Carnot map is in the order 0001 1110. And so
I got it now.
Yeah, I'm just continuing it to review for other people. So the column for G doesn't look exactly like the column for G in the truth table because these two are in a different order.
Thank you.
You're welcome. Okay, so now to get this one, I can wrap around like this. And to get that top one, I can do the four corners.
I forgot you can do that.
Yeah.
I remember you saying that that could have been on the final.
Yeah. I wonder if it was.
It wasn't.
Oh, okay. All right. So this tells us that C equals, okay, the four corners have B0 and Y0, so B bar, Y bar, plus the bottom row has X, Y bar, plus the little group that wraps around on the bottom two has X, B bar. So B bar Y plus X, Y bar plus X, B bar. If I had to make this as a circuit, let's see, would it be easier for me to build this Is that any easier? I don't think so. That's not any easier. Okay. All right. Now let's do a Carnot map for D. And our 1, 0 are still don't cares. And for function f, D is 0D11.
So what's the difference between this one and the top one?
This is, I'm getting the outputs for D.
Oh, okay.
And G is 00DD. And H is 1100. So there are multiple ways of doing this that are equally as good. So like to get these two ones on the bottom right, I could circle these, which I'm going to do, or I could circle the two here and then wrap around to get the two on the other side. And to get these ones, the best way is to do that. So this was what C equals. And what D equals is that top circle is A X bar plus the bottom circle is X bar A. Now there is something I can do here for building the circuit that'll simplify that. Do y'all recognize that?
It's the same thing, so you just remove one at a time.
Oh wait, no, it shouldn't be the same thing. This this is X A bar, sorry. X A bar. So It's A X bar plus A bar X. So if you don't recognize that, that's the exclusive OR. So rather than having to use a NOT gate and two ANDs and an OR, I just have to use one chip. I just have to use the exclusive OR. Okay, so then I look at my two functions and I figure out what chips I need. I'll draw the circuit first. So I have, let me write it here, C equals B bar Y plus X Y bar plus X B bar. Now I'm just thinking out loud for a moment. If I did
C B bar Y bar or B bar Y?
it should have been B bar Y bar. Thank you. I like to drop the bars just for fun. B bar Y bar. I'm wondering, I'm not going to go back and redo it, but I'm wondering if I had assigned these differently. And this is something you might want to look at on yours. Yeah, if I had assigned these differently, so like if I had made F00 and 10, if I'd made that G, and then it didn't matter which I would have made these H, then to simplify this, it would have been much simpler because I could have gotten that and that and that wrapping around that way, which would have been a lot simpler. So I didn't though, but I could have. And so that would have just something to think about when you do yours. Go back and think, well, if I had assigned my functions differently, because you actually have to build these, and so since you actually have to build them, you want them to be as simple as possible. Okay, so I have A, B, X, and Y. And I need A exclusive OR X. And that gives me C. And I need B bar ANDed with X. And I need X ANDed with Y bar. And I need B bar ANDed with Y bar. And then I need to OR those all together.
By the way, I think you mixed up the endings. Where C is D should be, I believe.
Like that?
Yeah.
Okay. All right. So now I need to think about what chips I would need. So I need a NOT. I need a 2-input exclusive OR. I need a 2-input AND. and I need 3 of those. And I need either a 3 or a 2 input OR. If there's not a 3 input OR, which I think there's not, I can use a 2 input OR and double it up. So we'll see. So now we'll see what all we've got, what chips are available. So if you go to the course website, I cannot go to the course website. It's really going to make me turn it on my computer. Oh, great.
Supposed to bring that up around the girls, but
So if you go to lab resources and you go to chips available in the lab, (74X04) is the NOT. So y'all write these down so that you can tell me what they are. 74X04 is the NOT. 74X08 is the 2 input AND. And um, 74X32 is a 2 input OR. And the exclusive OR. Hello, I'm on speakerphone in the class. Oh, okay, all right, bye. And where's the exclusive OR? There it is. 74X86. X86 is the exclusive OR.
it's 36.
86.
86.
86.
Yeah. Oh.
Okay, so now if I go to the data sheets,
They were talking stuff. Gotta get there.
I thought you told me
what was the OR gate, for instance?
$74 X32.
Okay.
I think I missed this.
Okay, so the exclusive OR and the and the OR all look the same, so I didn't get a different chip for those, but the inverter is a little bit different. So the inverter is this one. Okay, so I just have those handy for when I'm going to get to that step. Okay, so let's call the NOT gate, I'll call that chip 1. And I'll call the XOR chip 2. The 2 input AND I'll call chip 3. And this is a 2 input OR, and I'll call that chip 4. Now in order to change this from a 3 input OR to a 2 input OR, I'll do the following. So I'll put 2 of them into the OR, and then OR the output of that with another OR. So that's how I changed it. Okay, so now the NOT was chip 1, so I'll put a 1 on each of those. The exclusive OR was chip 2, so I'll put a 2 there. The AND was chip 3, so I'll put a 3 on those. And the OR was chip 4, so I'll put a 4 on those. Now, if you look at the data sheet for the NOT, you'll see that your input is A and your output is Y. So your input, if I have something going into 1A, then the NOT of that comes out at 1Y. And those are pins 1 and 2, and then pins 3 and 4 are 2A and 2Y. So for my NOT gates, I will put this at 1A, which was pin 1, and this is 1Y, which was pin 2. And then this is going to be 2A, which is pin 1, and the output will be 2A, which is pin 3, and 2Y okay, so 1A goes to 1Y, 2A goes to 2Y, and that's pin 3 and pin 4, and that's our NOT gate. And then our AND gate, if you look at the AND gate, you have your inputs are A and B and your outputs are Y. So it's 1A, 1B, 1Y, 2A, 2B, 2Y, 3A, 3B, 3Y. And so these ANDs will be 1A, 1B, 1Y, 2A, 2B, 2Y, 3A, 3B, 3Y. And then you can get the pin numbers off of the chip. So the pins for 1A, 1B, 1Y are 1, 2, and 3. So that's 1, 2, 3. The pins for 2A, 2B, and 2Y are 4, 5, and 6. And the pins for 3A, 3B, and 3Y are 9, 10, and 8. So 3Y is 8, and these are 9 and 10. Now the OR works the same way, so I know this is going to be 1A, 1B, 1Y, and this will be 2A, 2B, and 2Y, and the pins are the same, so that'll be 1, 2, 3, and 2A is 4, 2B is 5, and 2Y is 6. And then for my exclusive OR, that's going to be 1A, 1B, and 1Y, and those will be pins 1, 2, and 3. So that is your chip layout. And then what you would do is you would get, you'll draw your actual chips, and you have a ground wire, and you'll connect all of them pin 7 to ground. And you'll have your VCC, that's your high voltage, and you'll connect VCC to pin 14 on all of them. And then you'll go through and you'll make all the connections that you have up here. Let's see, we said the NOT was pin 1. I don't know what I said they were, but I can just call those 1, 2, 3, and 4. And then I can use what I decided up here. So, for example, I see that B goes to pin 3 of chip 1. So B goes to pin 3 of chip 1. I see that A goes to pin 1 of chip 2. X goes to pin 2 of chip 3. X also goes to pin 4. Let's see. X goes to a lot of places. X goes to pin 2 of chip 3. It goes to pin 2 of chip 2. And it also goes to pin 4 of chip 3. And I'm going to stop drawing them from here because this is just a made-up one. It's not going to be the same as y'all's, but y'all see what to do from here? And you see how to, what you would do with this once you get to the lab. And you see why simplifying your circuit as much as possible will save you time. A lot easier to set up. So for instance, if I really had to do this, I would definitely go back and use the simpler one than the one that has all the parts. Okay, well, I'm going to stop this recording and go on to something new unless anyone has any questions. Yes?
It's kind of embarrassing, but
Don't.
I've realized that I'm just confused about the VCC output. Like, I understand that it's where the power goes in and goes out to the ground.
Yeah, no, there's nothing to worry about with that. Okay, so you always have to have a closed circuit. So you always have to have And so, you're in circuits now, right?
Yep.
Okay, so if I have a circuit, just, there's a regular circuit, it has to be closed. And so, I have to have, everything, in order to make this have a closed circuit, everything has to be attached to the ground, and then also have an attached to the high voltage, to the battery.
Right, so whenever we're in circuits and there's no ground, there is a, like, wait,
There doesn't have to be a ground, but you can set anything you want. There is a lowest voltage point on the circuit, and we call it ground because we ground things, and so we make them actually enter to the ground. But that is going to be, I say it's the lowest voltage point on the circuit. It's not always the lowest voltage point on the circuit, but it's the point that you assign to be 0. And so the ground on the training kit is 0 volts relative to the 5 volts of the high voltage. So it's just they're 5 voltage, they're apart by 5 voltage, by 5 volts, the voltage difference. And that's what you need in order to drive the current.
Alright.
So it won't work without that, because otherwise you'll have an open circuit. And an open circuit,
Okay.
yep,
I'm sorry. Go ahead.
yeah. And if you have an open circuit, the current's not going to flow.
Alrighty. Yeah, so I always just thought of this circuit's endpoint as being like the LED lights being lit up. So that was where my
Yeah, so the LED is actually this.
It's a part of the circuit.
It's a part of the circuit. The circuit has to be, a complete whole. I was actually talking to Dr. Trahan about this. That did you play with? You see, when I was little, I played with a circuits kit. Did you play with the circuits kit when you were little?
I had once or twice.
And so I wonder if they make them like the way that they used to be made. It's like when I played with it, I realized you had to do that. So it's something like I learned early on. And we said it was a shame that more kids didn't play with circuit kits. So anyway, so does that help?
Yeah, it's I mean, yeah, I understand it's needed for the complete circuit, and that's where the power flows through.
Right. And so like and that's what's needed in order to make it work.
I have something.
Yeah.
So in the pre-lab, so just the lab in general, everything about it is worded poorly, in my opinion. I don't understand what.
I hope you're not watching this, Dr. Trahan. Go ahead.
Sorry about that.
Yeah.
Anyways.
So the idea is that you're supposed to be able to make some decisions on your own. So
I understand, but it says design a circuit with 2 control inputs, I and J. Would those control inputs be like
they're
F,
switches.
G, and H?
No, they're switches. And so I agree with you on this. The only way I ever learned like the terminology in different classes is like it's stuff that is so like ingrained to people who use it every day, and yet the first time you see it you don't know what it is. And so like you read that and that kind of looks like, well, what does this even mean? And so so read it to me again.
It says design a circuit with 2 control inputs, I and J, 2 data inputs, X and Y. X and Y. And 2 outputs, B and C. Each of these values is 1 bit.
Yeah. Okay. So I was just as guilty of this is because I simplified this even further, and so just assumed that you would know what this meant. And so what this means is that I have 4 bits in all coming in, so 4 bits, and 2 bits coming out. And inputs are generally going to be switches. And so you have switches on the kit, and the switches can either be on or off. And if they're on, that's 1, and if they're off, that's 0. So 2 control inputs, I and J. There's nothing special about the word control, except it's telling you that's what you're using them for. So you have your trainer kit, and I think it has 7 switches. 8. Okay. And so that just means you're going to pick 2 of these to stand for I and J. And I and J are the ones that are going to tell you which function you're going to use. And so you decide this on your own. So if you decide that IJ equals 0, 0 means function F, when it's time for you to demonstrate function F, you make sure both of these are off. And when it's time for you to demonstrate function H, if you decided IJ equals 1, 1 is H, you would turn them both on. So I and J, that's what that is for. So you use I and J to set which function you're using.
And the I and J is like the switches? at the
There are
bottom?
2 switches, like maybe these are switches 6 and 7.
Yeah.
6 and 7. Okay, and then you'll have 2 more switches, and you'll decide which ones you want to use for those. Maybe
Okay.
1 and 2 that are going to be A and B.
Okay, so on a, is it Carnot map,
Uh-huh.
I and J would be like, yeah, I don't know how to describe it. It would be like A and B, right? Like,
They were my A and B, yeah.
Okay.
yeah.
And then X and Y would be X and Y.
X and Y, B, X and Y. Yeah.
B and C would,
C would be the output, so that would be C and D.
It'd be my C and D. Yeah.
okay.
And then the way that's going to work when you actually design it is the C and D are going to be the LEDs.
Yeah, I can see it now, like what the wording means.
Uh-huh.
Like a lot more clear.
Right.
Because input just means like, and y'all was like switch. you know?
Yeah, so in other, is that?
Yeah,
Okay, and so the name for this,
that makes a lot more.
the name for this is control. And
Okay.
so when you're saying, when you're using something to control for something else, that's what that is. That's a control. So I and J control which function you're going to be using.
I see. Okay.
Yeah, I remember my first week in college, I was taking my math class, and I'd been really good at math. And I was all ready, and it's like, I'm all ready to be this great student. And I go home, and I look at the homework, and I have no idea what the notation means. And it was something very similar. It's just something, is like, have y'all ever seen real numbers, written like this?
Yeah.
And when you talk about domain and range of a function, you can write it like this. You can say your domain is the reals and your range is the reals. But I had never seen that before. And so I had this homework that just had F:(R) to R. And I had no idea what it was, and I was like, I hate school. I don't ever want to go to school again. But yeah, so notation can really be something until you get used to it. All right, any other questions? All righty.